All right, in this lesson, we're going to talk about all of the possible outcomes of an experiment. All right, anytime that you have all the possible outcomes of an experiment, that's called the sample space. All right, because if you have a number cube and you roll a number cube, you can roll a 1, you can roll a 2, a 3, a 4, a 5, or a 6 when you roll it. So that means that there are 6 possible outcomes. If you have multiple events, then you're going to have more possible outcomes. All right, and in order to find that, you can make an organized list to show all of those possible outcomes. All right, so in our first example, we have 2 bags. One bag has a red tile, a blue tile, and a green tile, and the second bag has a red tile and a blue tile. Okay, so if Vincent draws the tile from each bag, what are the possible outcomes? Well, so suppose he draws a red one first, okay? If he draws a red one out of the first bag, then on the second one, he can draw either another red one, or he can have a red one and draw a blue one, okay? If he draws a blue tile out of the first bag, then he can, in the second bag, he can draw a red tile, or he can draw a blue and then another blue one out of the second bag. All right. And the last choice is that he draws a green tile out of the first bag and draws a red tile out of the second bag, or he draws a green tile out of the first bag and draws a blue tile out of the second bag. Okay, so those are all the different combinations: a red-red or red-blue, a blue-red or a blue-blue, a green-red or a green-blue. Okay, so this is one way of doing it. We could have also said red goes to red or blue. Okay, blue goes to red or blue, or green goes to red or blue. Either way, it's the same way, just a different way of organizing. So it says how many outcomes are in the sample space? Well, we count here 1, 2, 3, 4, 5, 6. Okay, so there would be 6 outcomes. Here, same thing. Okay, how many? Red, 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 blue, blue, red, blue, blue, green, red, green, blue. 6. So there's 6 outcomes there. Okay. All right. Darren has 2 bags of marbles. Okay. One has a green marble and a red marble, and the second bag has a blue and a red marble. All right. So he draws a marble from each bag. So what are all the possible outcomes? Well, I'm going to do the thing with the little tree. So a green marble or a red marble. If he draws a green marble, he can draw a blue one, or he can draw a red one. If he draws a red one, he can draw a blue one, or he can draw a red one. Okay? So how many outcomes are there? 1, 2, 3, 4. So there are 4 possible outcomes. All right? Hopefully you guys are starting to see a pattern here. If you haven't seen a pattern yet, pay attention, okay? See if you can figure out what the pattern is. So there's 4 cards and 2 tiles in a board game. The cards are labeled N, S, E, and W. Okay, and the tiles are numbered 1 and 2. Okay, so there's 4 and 2. Okay, so N, S, E, and W, and they're labeled 1 and labeled 2. So he draws an N card. He can then draw a tile, number 1 tile or a number 2 tile. If he draws a S card, he can draw a number 1 tile or a number 2 tile. E, a 1 tile or a 2 tile, and W, a 1 tile or a 2 tile. Well, so those are all the possible outcomes, okay? And how many outcomes are in the sample space? Well, 1, 2, 3, 4, 5, 6, 7, 8, okay? So there are 8 possible outcomes, all right? Another example, 2 marbles and 3 cubes, okay? The marbles are pink and green. Pay attention here to 2 and 3, okay? So the marbles are pink and green, and the cubes are numbered 1, 2, and 3, okay? So he randomly selects 1 marble and 1 cube, so we have a 1. He could choose a 1, he could choose a 2, or he could choose a 3. For the green, a 1, a 2, or a 3. So if we count up, these are all the possible outcomes. If we count up how many of them there are, we can see that there are 6 possible outcomes. So hopefully you guys have figured out what the little pattern is, okay? This is called the fundamental counting principle. Says that you can find the total number of outcomes for 2 or more experiments by multiplying the number of outcomes for each separate experiment. So let's go back, okay? 2 bags of marbles, okay? It has 2 bags of marbles. One has a green and a red, so those are 2 choices. And the other one has 2 choices as well. 2 times 2 is 4, okay? 4 cards, 2 tiles. 4 times 2 is 8, okay? 2 marbles and 3 cubes. 2 times 3 is 6, all right? So that, you know, the examples we've done so far have been pretty straightforward with lower numbers, okay? But this fundamental counting principle allows us to do more complex experiments, all right? So Carrie rolls 2 number cubes, 1 through 6, and how many possible outcomes are there? So cube 1 has 6 outcomes, 1, 2, 3, 4, 5, and 6. And cube 2 also has 6 outcomes, okay? So the possible outcomes are 6 times 6, which is 36, okay? So there are 36 possible outcomes, and it's easy. I mean, it's sort of tedious, I guess, to try to list all of them. So I'm not going to. But if you think about it, if you roll a 1 on the first one, then you could roll a 1 or a 2 or a 3 or a 4 or a 5 or a 6. Okay, so you could do, you could do all that. And then if you did a 2 and did the same exact thing over and over again, then eventually you would end up that, just by listing all of them, you would end up that there are 36 possible outcomes, okay? All right, so Sammy picks 3 number cubes, 1 through 5, okay, that are numbered 1 through 5. After she picks the number cube, she puts it back in the bag, so she's only got 1 bag, but she'll pick 2 number cubes out of that, okay? So, and then she puts it back. So how many outcomes are possible? Well, first of all, she has 5 outcomes for the first one, puts it back in, 5 more outcomes for the second one, and 5 more outcomes for the third one, and 5 times 5 times 5 is 125 outcomes, okay? All right, so that does it for this lesson. Make sure that you've copied down all your notes and make sure you ask questions. I'll talk to y'all later on.